Can the movement of electrons in ionized compounds be enhanced by applying other chemical or physical properties, such as heating or adding other substances like water? Yes, the movement of electrons in ionized compounds can be enhanced by applying other chemical or physical properties. By adjusting various conditions or changing the chemical situation, we can control the behavior of ions in ionic compounds. Here are a few examples. Temperature control. Heating a compound can increase the thermal motion of molecules and ions, which can also lead to more active electron movement. At higher temperatures, ions move with more thermal energy, which can increase the rate of chemical reactions or improve ion mobility. Addition of a solvent. Adding another substance, such as a solvent, to a compound can increase the mobility of ions. Solvents can act to reduce or disperse the interactions between ions, which can lead to increased ion movement. Application of an electric field. An electric field can be used to move ions. This can cause ions to move in the direction of the electric field, generating an electric current in an electrolyte or promoting other chemical reactions. Type and concentration of the substance. Adding other ions to a compound can change the chemical interactions. The interactions between ions can vary depending on the type and concentration of the substance, which can lead to changes in properties such as chemical reactions or solubility. Therefore, by controlling the physical and chemical conditions of a compound, we can control and regulate the movement and interactions of ions in an ionized state. This plays an important role in chemical and physical research. The movement of electrons in ionized compounds can be enhanced by applying other chemical or physical properties. This can be done by heating the compound, adding a solvent, applying an electric field, or changing the type or concentration of the substance. Do electrons or atoms in a solid move? Yes, electrons and atoms in a solid do move. Even in the solid state, particles can move in a variety of ways, including vibration, rotation, and movement within the material. These movements change depending on the temperature and energy state of the material, and they affect the physical and electrical properties of the material. Vibration. Atoms or ions in the solid state move by vibrating around their position. This vibration is related to temperature, and as the temperature increases, the vibration of the particles becomes more active. Rotation. Atoms within molecules can rotate around each other. This rotation continues to occur in the solid state, and it can vary depending on the molecular structure of the material and the temperature. Movement. Particles within the material can also change position within the structure of the solid. However, the structure of the solid is relatively stable, so particles do not move large distances. In addition, electrons in the solid state can move around the atom and exist in electron orbits with different energy levels. This is known as the electron cloud or electron level, and when the energy level of an electron changes, the electron can move to a specific energy state. These movements and changes in energy levels play an important role in determining the physical, electrical, and thermal properties of a solid material. Therefore, understanding these movements and interactions is important for studying and explaining the properties of solid materials. Yes, electrons and atoms in a solid do move. These movements include vibration, rotation, and movement within the material. They are affected by the temperature and energy state of the material, and they affect the physical and electrical properties of the material. Do electrons in conductors move more actively than those in insulators in solids? Yes, electrons in conductors move more actively than those in insulators in solids. This is one of the main differences between conductors and insulators. Conductors are materials in which electrons can move relatively freely, and the surrounding atomic structure of the electron does not interfere significantly with the electron's movement. Within conductors, electrons are carried by an electric field to generate an electric current or to enable the movement of electrons in electrically connected devices. On the other hand, the movement of electrons in insulators is much more limited. The atomic or molecular structure of the insulator makes it difficult for electrons to move, and electrons are relatively fixed to their electron levels, energy levels. Therefore, the mobility of electrons is much lower than in conductors, and the energy required to move electrons is also higher. The more active movement of electrons in conductors is one of the reasons why conductors can effectively carry electric current and play an important role in a variety of applications related to electrical connections. Conductors are used to carry current in electrically connected circuits or to transmit electrical signals because they allow the movement of electrons. Electrons in conductors move more actively than those in insulators in solids. This is because the atomic structure of conductors allows electrons to move freely, while the atomic structure of insulators restricts the movement of electrons.